You know, of all the incredible things in the universe, you could make a pretty strong case that the human brain is the most complex. I mean, think about it. It's this 3-pound lump of tissue that can wonder about distant galaxies, create art that moves us to tears, and even try to understand itself. So, what is it that makes our brains so uniquely powerful? Well, today we're diving into that, and we're going to look at what might just be the brain's master switch.
Right, so the secret isn't just about being big. Plenty of animals have big brains. The real magic, it turns out, is in how our brain is organized, and in this hidden molecular architect that really we're only just starting to appreciate. This is the story of how one tiny molecule might have been the driving force behind the entire evolution of the human mind.
Okay, so to unravel this whole thing, we have to start at the absolute top. I'm talking about the part of the brain's processing hierarchy that really sets us apart from all our primate relatives. This is our cognitive command center.
Now, scientists have a name for it, of course, the transmodal cortex, but a much better way to think about it is as the brain's CEO. This part of the brain doesn't really get bogged down in the raw data coming in from your eyes and ears every second. Nope. Its job is to take all that information, put it together, see the big picture, and then enable all our most sophisticated tricks. You know, abstract thought, planning for the future, and our own rich internal world of memories.
Here's a great way to picture it. Imagine the brain as a big company. Way down at the bottom, you've got the unimodal cortex. This is like the mailroom. It handles one specific thing, raw data from a single sense, like vision or sound. It's super concrete, super specialized. But way up at the top, you've got the transmodal cortex. That's the boardroom. This is where all those different streams of information finally come together to create these big, abstract ideas and flexible strategies. And it's this exact hierarchy that lets us do all the amazing, complex thinking that we do.
So we've kind of known about this basic structure for a while, but the big question has always been how? How did our brain's boardroom get so ridiculously powerful and so much bigger during our evolution? Well, the answer isn't in the structure itself, but in a tiny little molecule that's been hiding there in plain sight.
And here it is, our first major clue. When scientists started mapping the brain in incredible detail, they found something really strange. This transmodal cortex, the CEO of the brain, is absolutely swimming in one specific molecule, the serotonin 2A receptor, or just 5-HT2AR for short. I mean, it is just packed with these things.
And that, right there, leads us to the central mystery that a really groundbreaking paper from 2023 set out to solve. Why? Why would this one specific receptor be so densely clustered in the most evolutionarily advanced, the most abstract part of our entire brain? Is that just a weird coincidence? Or is it the key to the entire puzzle?
And the answer they found, well, it's pretty mind-blowing. It turns out the 5-H2A receptor wasn't just living in the command center, it was the master architect that actually built it. See, during early brain development, growth is driven by these special cells called progenitor cells. And what this new research shows is that signaling through the 5-H2A receptor basically sends a powerful command to these cells: multiply, make more of yourselves, go, go, go. And it was this insane multiplication that fueled the massive expansion of our advanced cortex.
And just to give you an idea of the scale we're talking about here, it is staggering. In us humans, these key architect cells make up over 75% of the total pool of these cells. Now compare that to a rodent. You know how much they have? Just 10%. So this 5-HT2A-driven engine is one of the main reasons our cortex is so uniquely complex. It literally built more of the brain's most valuable real estate.
Okay, so this receptor was a key architect in our brain's evolution. That's an amazing story on its own. But what about now? What does it do in an adult brain? Well, it turns out the architect didn't just build the thing and then retire. It actually still holds a master key to remodel the very structure it created.
And this is the part that is so exciting for us today. When you activate that same 5-HT2A receptor in an adult, it reopens this incredible window of what's called neuroplasticity. It's like you're temporarily turning the brain back to a more youthful, more flexible state where it can learn and adapt and change way more easily. The architect is basically being called back in to do some renovations.
So how do you turn this key? Well, there are two main ways. One is endogenous, from inside the body. During periods of really high stress, the body can release this massive flood of its own serotonin, which naturally activates the system, probably is a powerful way to help us adapt and cope. The other way is exogenous, from outside.
This happens with certain compounds like psilocybin, which famously bind to and directly switch on these exact same 5-HT2A receptors.
And when we say plasticity, what does that actually look like? Well, it seems to happen on 3 different levels. Anatomically, it can actually help grow new physical connections between your neurons. Functionally, it allows for totally new patterns of communication to emerge across the brain. And behaviorally, all that adds up to more cognitive and psychological flexibility. Basically, the ability to change your mind and break out of old habits.
So, to really get this, let's go back to that company analogy. On a normal day, a healthy, efficient brain runs on a pretty strict hierarchy, right? Information flows up the corporate ladder from the mailroom all the way up to the boardroom. It's constrained, it's predictable, and it's really optimized for just getting through the day.
But activating this 5-HT2A system, it's like someone grabs the brain and just shakes it like a snow globe. That strict hierarchy temporarily flattens out. All of a sudden, the mailroom is talking directly to the legal department, and marketing is brainstorming with the folks in accounting. You get these totally new, novel lines of communication opening up across the entire brain. It's this chaotic, but also incredibly creative state that allows the brain to explore new solutions and bust out of its most rigid patterns.
So when you put all of these pieces together, what you get is this grand, unified theory. It's a theory that connects our deep evolutionary past, the way our individual brains develop, and its incredible potential for change right here in the present.
And this is the core idea, right from the researchers themselves. The 5-HT2A receptor isn't just one thing. It plays this incredible dual role. First, it was a developmental driver. It physically built the top of our brain's hierarchy. And now, in all of us, it acts as an adult modulator, holding the keys to flexibly reshape that very same system.
And look, this is way more than just a cool biology story. This has huge implications. This is exactly why researchers are so intensely interested in this system as a tool for therapy. I mean, think about conditions like depression or addiction. So often they're defined by these really rigid, stuck, harmful patterns of thought. Well, activating this system could provide the critical window to actually change those patterns. Because at the end of the day, this induced plasticity, this shaking of the snow globe, it's not about erasing anything. It's about creating the opportunity to unlearn. It gives the brain a precious chance to weaken those well-worn, unhealthy pathways of thought and behavior, and, with the right support, to start forging new, healthier ones. Which leaves us with this one final, pretty powerful question to think about. Isn't it a remarkable idea that the very same molecular switch that helped build our complex, conscious minds in the first place might also hold the master key to remodeling them and ourselves for a better future?